Welcome back to Data Explained. In this episode, we're tackling one of the most quoted and most misunderstood ideas in distributed systems, the CAP Theorem. It's the rule behind every distributed database design, and it tells us something uncomfortable. When it comes to consistency, availability, and partition tolerance, you only get to pick two. The idea of a system that's both strongly consistent and always available. That's a myth, and we're about to see why. To see where that myth breaks down, picture the setup from last episode. Your database replicated across servers for safety. Now imagine the network link between two of them quietly drops. A write comes in, lands on one side, and the other side never hears about it. Suddenly your copies disagree, and you're stuck with a question. Do you reject requests to stay correct or keep serving and risk handing back stale data? That choice right there is what the CAP theorem is really about. CAP gives us three names for what we actually want. Consistency means every read reflects the most recent write. All copies tell the same story. Availability means every request comes back with a real answer, not an error. And partition tolerance means the system keeps functioning even when the network splinters. Brewer's theorem from 2000 is the uncomfortable punchline. In a distributed system, you only get to guarantee two of these at once. To make that trade-off concrete, picture two shop counters sharing one stock list over a phone line. The phone goes dead. That's your network partition. A customer wants the last item at counter A. Counter A can refuse the sale until it reconfirms with B. That's consistency, but the customer walks away empty-handed. Or it can sell anyway and risk B selling the same item. That's availability, at the cost of consistency. You genuinely cannot have both. That's CAP in one shop. So here's the triangle that frames the whole debate. Each edge is a pair you're allowed to keep, CA, CP, or AP. But here's the catch. In any real distributed system, the network will eventually split. Packets get dropped, links flap, a switch reboots. That makes P non-negotiable, which collapses your menu down to two real options: CP or AP, consistency or availability when things go wrong. That's the choice you're actually making. And this is where most CAP diagrams quietly lie to you. They show three equal options, but CA, consistent and available with no partition tolerance, really only exists on a single box sitting under your desk. The moment you span two machines, a network or a data center, partitions are a fact of life, not a feature you toggle. So the honest question isn't which two do I want? It's when the split happens, do I freeze writes to stay correct or keep serving and let copies drift? CP or AP? Let's take CP first. When a partition hits, a CP system would rather throw an error or just make you wait than hand back data it isn't sure about. You lose a little availability, but you never lie to the caller. That's exactly what you want for banking, payments, or inventory data. A brief outage beats double charging a customer. It's also why most SQL setups, MongoDB by default, HBase, Zookeeper, and etcd all land on this side of the fence. Flip that around and you get AP. Here, every node keeps answering during a partition, even if it's working from a slightly stale copy. And once the network heals, the system quietly reconciles the differences. That's the right call for feeds. Shopping carts, likes, metrics, anywhere staying online matters more than being perfectly up to date. Cassandra, DynamoDB, React, and CouchDB are the usual suspects, the classic base, eventually consistent crowd. Let's put them side by side. When the network splits, CP refuses or errors out to stay correct, while AP keeps serving, even if the answer's a little stale. So CP feels like, try again in a moment. You reach for it when wrong data is expensive. AP feels like, always on, maybe old. You reach for it when downtime is what really hurts. Same trade-off. Two different answers to the question of what you're willing to give up. And if that framing sounds familiar, it should. This is exactly where ACID and base come from. Remember those from the SQL versus NoSQL discussion. ACID databases, the classic SQL crowd, lean CP, correctness above all else. Base systems, the NoSQL world. Lean AP. Stay available. Let consistency catch up later. Think of CAP as the physics of the situation, and ACID and BASE as the design philosophies engineers built on top of it. So, when we say an AP system is eventually consistent, what does that actually mean in practice? Picture a right landing on node A. For a brief moment, nodes B and C haven't heard about it yet. Reads from them might be stale, but the update propagates, and given a little time without new writes, every node converges on the same value. The disagreement is temporary. That's the price of staying always on. So how do you actually choose? Think feature by feature. A bank balance has to be CP. You simply cannot show someone money that isn't really there. Same with stock at checkout. Overselling the last item is a real problem. But a shopping cart, keep it open for writes, always. That's AP, and likes or view counts. A slightly stale number is genuinely fine. Big systems aren't one or the other. They're CP in the places that matter and AP everywhere else. Before we move on, let's clear up 3 myths that trip people up. First, you don't permanently pick 2 of 3. The trade-off only bites during an actual partition. The rest of the time, you happily get both consistency and availability. Second, true CA systems at scale don't really exist. Drop partition tolerance and you've basically got one node. And third, eventually consistent doesn't mean unreliable. It's a deliberate trade-off where copies converge, not broken, just not instant. Which brings us neatly to PACELC. Think of it as CAP with the missing half filled in. The rule goes, if there's a partition, you still pick availability or consistency, just like before. But else, meaning the network is healthy, you're trading latency against consistency. Because even on a perfect day, keeping every replica perfectly in sync takes time, and that time shows up in your response latency. With the theory in hand, let's see how real databases line up. On the CP side, you've got PostgreSQL leaning into strong consistency, MongoDB defaulting to CP but letting you tune it, and etcd and Zookeeper, the classic coordination crowd, where correctness is non-negotiable. On the AP side, Cassandra and DynamoDB favor staying available with eventual consistency, while React and CouchDB are designed to always accept a write. And here's the nuance. Most modern systems are tunable, so you can pick CP or AP per query, per table, even per operation. So let's pull the threads together. CAP names 3 properties: consistency, availability, and partition tolerance. And a distributed system can only fully guarantee 2 of them. But since partitions will happen whether you like it or not, P isn't really on the table. The real decision is what you do during a split CP or AP. And as a rough mental shortcut, ACID-style databases tend to lean CP, while base-style systems lean AP. And if you only remember one thing from this whole episode, make it this question: when the network splits, would you rather be wrong or be down? If the answer is never wrong, think money movements, stock counts, anything where a bad number has real consequences, you go CP. If the answer is never down, social feeds, shopping carts, things where a slightly stale view is fine, you go AP. That's the whole decision in one line. If you want to keep going from here, the Data Explained series walks through the neighbors of this topic: ACID and sharding, caching and queues, dempotency, replication, and of course, CAP itself, so the pieces start clicking together. And when you're ready to move from theory into practice, actually picking a database, tuning consistency, hardening replication, the full courses over at dargslan.com courses are where that work lives. Before we wrap, I want to turn the mic around for the system you're working on right now. Would you rather be briefly wrong or briefly down? That's really the CP versus AP question in plain clothes. And if you've ever been bitten by eventual consistency out in the wild, a stale read at the worst possible moment, I'd genuinely love to hear the story. Drop it in the comments. And that's a wrap on CAP, and honestly, on the whole data series. Once you see this trade-off, you start spotting it everywhere. in replication choices, in failover behavior, in those quiet little config flags nobody reads. If this clicked for you, hit subscribe so you don't miss the next one, and swing by dargslan.com for the deeper write-ups. Thanks for watching. See you in the next episode.